The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Number 6, this problem is maybe a little bit tricky to actually determine what's going on here. Viewed at night from the high diving board at a swimming pool, the light from an underwater bulb forms a bright 10-foot diameter circle on the surface of the water. How far below the pool's surface is the bulb? So what we need to do here is first let's draw a picture. So we have the surface of the water and there's a bulb on the bottom, and we don't know how deep it is. But of course light rays are coming from this bulb in all directions. So there's ones going straight up, like this, etc. Obviously on the other side the same thing. So what's going on here is that at some point, because we're going from water to air, n equals 1.33 to n equals 1, at some point, at some angle, we're going to get total internal reflection from the water, or the rays that are coming from the light bulb. And therefore, at some point here, these rays are not going to escape into the air, and that would be the edge of the circle of light you would see if you were above the water. So that's what we need to find here, is the critical angle. So let's set up Snell's law for the critical angle. So we have n1 sine theta 1 equals n2 sine theta 2, of course. So in this case, what are our angles going to be? Well, let's say n1 is the water and n2 is the air. So let's say that this last one that I just drew here is going to be your angle, or your one that gives you total internal reflection. So we want our incoming angles to have an output angle of 90 degrees. So we don't know what our incoming angle is, but we know that in n2 we want it to be sine of 90. Sine of 90 is 1. So we get sine theta 1 equals 1 over 1.33. And we can solve for that. So let me do that real quick. So we get an angle of 48.75 as our critical angle. Okay, so let's think about what that means. So that's this angle right here is 48.75 degrees. So that is the last ray that is on the edge of our circle. So what you can think is now I have a right triangle that goes to the light bulb up to the surface where the edge is going to stop, and that has the depth. So then you can see that since we knew that the diameter of the light up here was 10 feet, that means this part of our right triangle must be 5 feet. And if you have 5 feet and you know the angle is 48.75 degrees, using tangent, you could find this side. So what we have is tangent of 48.75 is equal to, let's call this x, is equal to 5 over x, opposite over adjacent. So again, this is just a matter of figuring this one out here. So let me do that again real quick. So we would have 5 divided by that tangent. And we get an answer of 4.4 for x. 4.4 feet. So that must be how deep the light bulb is in the pool. Answer choice 1, 4.4.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.